What would you see if you stood at the edge of a black hole and looked back? You'd see 100 versions of yourself. No, this isn't magic. It's the photon sphere. In just 15 seconds, not even the light from your own eyes can escape. Today, we're diving into a hardcore physics topic. What happens if we throw you into a black hole? This isn't science fiction. It's a solid speculation based on real physics. Before we get to the throwing part, let's quickly review what a black hole is. Even the genius Albert Einstein once called them God divided by zero because he didn't believe they could actually exist. But guess what? Humanity found them anyway. When a supermassive star runs out of fuel, it collapses under its own immense gravity into an infinitely dense point called a singularity. According to general relativity, gravity isn't a force, but a curvature of space-time caused by mass. A black hole is so dense that it warps space-time into an incredibly deep well with almost vertical walls. Inside, there's no solid surface, just that singularity, so powerful that nothing can escape its pull. Interestingly, back in 1939, Einstein himself published a paper arguing that stars couldn't possibly collapse into singularities. But in that same year, Oppenheimer and physicist Hartland Snyder predicted that stars could indeed collapse under their own gravity to form black holes. Now, what if we throw you into one? The crazy thing about black holes is that anything can become one-stars, planets. Even you, as long as you're compressed down to your Schwarzschild radius. For our sun, that's a sphere just 3 kilometers across. For Earth, it's about the size of a marble. For a person, it's a size far smaller than a single proton. So, which black hole should we pick for this little adventure? Let's go big. Small black holes are boring. Let's choose the one right in our cosmic backyard, Sagittarius A*, the supermassive black hole at the center of our Milky Way. You're actually orbiting it right now. Imagine this. You and I fly our spaceship to about 1 trillion meters from its event horizon. I'll stay on the ship to watch while you begin your journey towards the black hole. We'll each have a special watch to track our own elapsed time. We sync them up and you're off. As you fall, you see the black hole feasting on surrounding matter, creating a spectacular glowing disk. After about 30 minutes from your perspective, you've covered just 0.1% of the distance. On my ship, I've only aged 11 seconds more than you. No big deal, right? But as you get closer, things get weird. The black hole's gravity bends light, creating bizarre visual distortions. You check your watch again. For you, 2 hours have passed. For me, I'm now 44 seconds ahead of you. The black hole's shadow also seems to grow much faster than it should, thanks to gravitational lensing. A long while later, you check your watch again, and it's a shocker. From your point of view, you left the ship 12 hours ago. But from my perspective on the ship, I've been watching you fall for nearly 15 and a half hours. Now, just before you reach the point of no return, you enter a truly magical place, the photon sphere. Here, gravity is so perfectly balanced that photons particles of light can get trapped in orbit. If you could freeze time and look around, you would see multiple copies of the back of your own head as light from your body circles the black hole and returns to your eyes. You push on past the photon sphere and the event horizon looms. The black hole fills your entire view. You've been falling for 13 hours. In just 24 minutes, you will cross over, for me, back on the ship. Nearly 20 hours have passed. 18 minutes later, you check your watch. Your 18 minutes have lasted 18 hours for me. The final moment arrives. You have 6 minutes until you cross the event horizon. You take a deep breath and check your watch one last time, but it seems broken. It says, "I've been observing you for an infinite amount of time." It's not broken. Physics is just that wild. From my ship, I would watch you for decades, slowly approaching the event horizon, red-shifting until you fade away. I would never, ever see you cross it. For me, your last 6 minutes last an eternity. It sounds like a daydream, but it's straight from Einstein's equations. And then you're inside. Strangely, you might not even notice the moment you crossed over. You can still see the stars and our ship, but now that light, just like you, is doomed to fall into the singularity. You've passed the point of no return. As you approach the infinitely dense center, your body gets stretched like spaghetti, a process literally called spaghettification. Eventually, you merge with the singularity, becoming one with the black hole. This entire journey is both spine-chilling and completely fascinating. Black holes are mysteries that make us feel both awe and a healthy amount of fear. Thanks for watching, and if you enjoyed this cosmic trip, don't forget to like and subscribe for more deep dives into the universe.